Okay, students, here we have sort of animation and simulation, you can say, which will help us to understand what is going on when we have a particular mass and, of course, the density of a liquid. On the right side of this animation, you can see the calculation, and here you have a block of mass 2.89 kg. The object volume, as you can see here, is taken as 5, nearly 5 here. So this is what we have. The liquid density on the left side, you can see, is 1000 kg per meter cube. And as far as the situation is concerned, the calculation is showing you that you have the equation F is equal to rho, the density of the fluid, g, acceleration due to gravity, and v, the volume submerged. So what is the situation here? The upward force, which is the buoyancy force or upthrust, you can say, is 50.3 Newton. On the other hand, when you will see the weight is 28.9. So as far as the net force is concerned, here you can see the net force is equal to weight plus the FB, and one of the way of the force, which is weight, we have taken as negative, and this is equal to ma. So when you will calculate the acceleration, you will get the value 7.4. And what we can see here, that the acceleration is upward acceleration, yani the upthrust is greater than the value of the weight at this stage. Of course, when you will reset and check it again, the upward force is 50.3, which is the upthrust, and you have the weight, which is 28.9. So what is happening in this case? The upward force is greater, so you have a resultant force, and when you will apply the concept of F is equal to ma, of course the acceleration will be in the direction of the resultant force, which is upward. And what you can see, the block is moving up because the resultant force is greater in the upward direction, or simply you can say the upthrust is greater than weight. So the body is just going towards the floating situation, you can say. Now if you will reset, and here if you will increase the weight, then what will happen? Suppose this is the situation and somewhere here we are. So the calculation, yeah, you can see is again the weight you have, and the upward force you have. The upward force is 50.3. The volume is same as before, and the density is same as before. So the water displaced, or the fluid displaced by, or liquid displaced by this block, is giving you the concept of the upthrust. So this is nothing but 50.3. So 50.3 is the upthrust, but this time you have taken a greater weight. So what will happen? You can see here that the weight, of course, is greater than the upthrust. So the weight is greater means the net force is downward force, and here you can see the acceleration, which is the downward acceleration, minus 2.41. So what will happen in this case? The body is going towards the bottom of the tank. So ultimately you can see that it will sink, simply you can say. And when it will be at the bottom, again, with very simple thing, that you have the situation of your calculation. As you can see here, the upward force is nothing but the contact force of 16 Newton, and here you have the upthrust, which is 550.3. This was actually the force upthrust, which is 50.3, and this is nothing but equal to the weight. So in this case, when the block will go to the bottom, the overall, or the net force, will become 0, and simple thing is that, of course, the body will be at rest, no acceleration, a is equal to 0. So this is what you have here. You can see that what is going on, these are the forces, and ultimately the resultant force you have is 0. So of course the acceleration is also 0. So what actually we are concluding, that if the downward force, you can reset, if the downward force is greater than the upthrust or upward force, of course the body will sink. as we have you can say studied in theoretical part of this discussion. And when of course you will have upthrust is greater, and when it will be, when the mass of the body will be a small mass. So when you will have this situation, of course the upthrust is greater than the weight, and when you will check this time, you will see that the body is moving up. So the upthrust is taking your body towards the you can say top of the tank, or the highest level of the water, you can say. And this is what we have, the situation of the upthrust. And we have the term buoyancy as well. So this is what we have: buoyant force on a block, or upthrust on the block. So this is what we have as far as the you can say the explanation of upthrust and weight, as I have already explained this thing to you. Fine. Here we have another animation simulation, and this simulation is explaining the Archimedes principle. And what we have actually studied, that when you have a mass of, suppose in this case 200 gram, is hanging with the spring balance. So you can see the situation of the spring balance, which is showing you that you have a particular value in the spring balance. But when you will take the body into the liquid, then what you can see, the liquid is being displaced by this block, and it is going into another container. And what is happening, simply you can say that the block is completely immersed, and you can see here that the spring balance is showing you the lesser value. It means that, simple thing you can say is, when we will dip something into the, or when we will immerse something into the liquid, what will happen? The apparent weight of the body will decrease. So as you can see here, that instead of 3, now you have something like 2 point something on the scale. So this is important. And what actually we can determine, that here you have a particular weight in of the water displaced in another container, and this weight is actually giving you the concept that how much upthrust you have on this mass of 200 grams. So 2 points you have to remember. One is that when we will immerse the body into the liquid, there will be a loss of weight of the body, and the apparent weight will decrease. Similarly, here on the left side, you can see that we have 200 gram, and the meter is showing you this 200 gram. But when you will bring your block into the you can say liquid, or completely immersed, then what you can see here, that when it is completely immersed, the weight, or the mass, and ultimately the weight has decreased from 200 to 126 gram. And what we can say, that 74 is here in the container. On the other container, from your you can say measuring cylinder, the liquid has you can say moved to the dish, which is on the scale and showing you 74. So basically you can say that this 74 gram of water, which is of course you can calculate in terms of the weight as well, has been removed by this block, and this is nothing but the upthrust. So if you will calculate the upthrust with the help of this 74 multiplied by 9.8980, of course here you have the gram, so 980 will give you the ultimate calculation, that what is the loss over here. So this is not only the upthrust, but of course the loss of the mass in the block, which is of 200 gram. So again, 2 points you have to remember. One is that when you will immerse the block completely into the liquid, what will happen? There will be a loss of mass. This is one thing. As you can see that instead of 200, now your meter is showing you 126. The 74 gram of water has moved from the container, yani your measuring cylinder, to another dish, and this shows that how much upthrust you have. Yani simple thing is that if you will multiply this 74 by 980, so this will give you the force ultimately, and you can calculate the ultimate force in terms of the Newton as well. So this will be the upthrust. So how we can calculate the upthrust? By simply multiplying this mass. If you are considering this mass in grams, of course it is 74, but if you will consider the kg, then of course this will be 0.074, and this is 0.04 multiplied by 9.8, and this will give you the weight or the force in Newton, you can say, and that force is nothing but the upthrust. So I hope that this animation will help you to understand what actually we have already studied in the theoretical part. Okay dear, here we have another example in which we have aluminium block. In this case, this is aluminium block of mass 13.50, and when we are just putting this block into the tank, then the volume displays, you can see, is the 5 liter, and when you will calculate this in meter cube, this will be 0.005 meter cube. So the calculation is here, like here you have the upthrust, which is nothing but, here you have rho GV. So 1000 is the density of liquid, 9.8 is the value of G, and here you have the fluid displaced. So what is the situation here? You are getting 49 Newton force. 49 Newton force is the, you can say, the upthrust. When you will calculate the weight of the block, so this is very simple. The weight of the block is nothing but mg, as you have mass 13.5 and 9.8. When you will multiply these two figures, you are getting 132.3 Newton. So as you can see here, that the weight of the block in this case is greater than the upthrust. So you can say that here we have the weight which is greater in magnitude, and here we have the upthrust which is lesser in magnitude. So simple thing is that the body will sink or block will sink. So this is the situation over here. When you will consider, on the other hand, when you will consider here the wooden block only, then what will happen? You can see here you have the wooden block of mass 2 kg, and this block is displacing 2 liter. And basically the initial volume is 100 liter, and when you are putting this into the liquid, what you are getting? 102. So 2 liter is the displacement of the volume of the liquid, or you can say 0.002 meter cube. So when you will do the calculation for this block, what you have, the upthrust is nothing but your rho GV, and you have 1009.8 multiplied by the volume displaced, and what the force you are getting, the force is 19.6. This is the upthrust. Obviously here you have the upthrust. So what will happen when you will calculate the weight? So simple thing is that you have 2 kg multiply by 9.8, so 19.6 you are getting. So in case of wooden block, what you can see here, we have this situation that the weight is equal to the upthrust, and when you will have this situation, the block will float or floats. So this is something which is very important to understand, that what is the situation here in this case. So simply you can say that the downward force, which is of course the weight, and the upthrust, which is the upward force, when these forces are equal in magnitude, what will happen? The body floats, or the block floats on the surface of the liquid. So this is what we have, and you can do the same calculations for others as well. Like here, instead of suppose wood, you are considering the say brick, then again what will happen? It will go into the you can say tank, or you can say it will sink. So why it's sinking? Again, because the mass of this is 10 kg, and the displacement is here of 10 liter, which is nothing but 0.010. And when you will do the same calculation as I did, you will see that the upthrust is less than the weight, and because of the you can say situation, the brick will sink, as well as the aluminium. So this is what we have. But if instead of the aluminium, suppose you are considering the styrofoam, then what will happen? You can see that it's a jump sort of situation, because suddenly the upthrust is very high as compared to the weight. You can calculate the weight and you can calculate the upthrust yourself, and you will see that why it is going towards the top of the liquid. Simple thing is that the buoyancy force or upthrust in this case is very large as compared to the weight of this thing. So this is what we have. I hope through these three animations what I have explained theoretically, you will get the better understanding. If you are new on this channel, subscribe this channel and press the bell icon so you can get the new uploaded videos as soon as I will upload. And of course share and like these videos if you are getting something out of it. And of course when you will share, the other students will take the benefit of these lectures as well. So till the next lecture, Allah Hafiz, take care.